Oh hey, fancy seeing you here. I'm just kidding. This video is going to be that cheesy, but it's actually going to be about solids. Now, solids are one of the three states of matter. Particles that hold the solids together are held in a relatively fixed position. That means that they are rigid and they have edges, unlike liquids that don't have edges and fit to their container, and gases that go wherever they want. The attraction powers that hold the solids together are stronger than any other state of matter. That is what gives it the rigidness of what solids are known for. Hi, yeah, this is clearly another day because I'm wearing different clothes. Okay, so now there are two types of solids. There are crystalline solids and there are amorphous solids. Crystalline solids have repeating geometrical patterns, and they're also ordered and symmetrical. So an example would be this. This is symmetrical. This has patterns, and the solid that would be made out of these would be made out of entirely just these, connected side by side, up and down. Now amorphous solids, those are randomly arranged. They have no symmetry. They are whatever they want to be. As in this, there is no symmetry. These are randomly placed. And it just coincidentally looks like a duck. Okay. So now there are some characteristics that help define amorphouses from crystallines and just characterizes them as solids. Definite shape and volume. All solids have a definite shape and volume. That means that no matter what, they will never fluctuate like a liquid does. Crystalline solids break into tiny pieces, but those pieces represent the bigger shape of it. So this is a crystalline solid because it has a repeating pattern, 2, 1, 2, 1, and it also is in the shape of this. Now if I take a piece out, it still represents the shape. That is what a crystalline does when it breaks. Now an amorphous solid, when those break, they do not represent anything. Like glass, when that breaks, it doesn't represent the shape of the glass itself. It breaks into random little pieces. High density and incompressibility. Now, that means that solids are the most packed of the three states of matter. As in this, you don't see any air pockets, but there are air pockets. You just can't see them. And when it says incompressibility, it means it cannot be compressed whatsoever. Even though some things, like this plastic bag, looks like you can crumple it, bring it down into a smaller shape, you're not. It's actually just air pockets, and the air is leaving. So the material itself cannot be compressed any more than it is already. Sponges are another example of a porous solid. So the sponge itself, you can't compress anymore, but when you squeeze it, the air leaves the pockets, which makes it incompressible, I guess. Low rate of diffusion. All solids have a rate of diffusion, but it is so minimal that you can barely tell what it is. So, for an example, two solids that do fuse are zinc in this penny and iron in this screw. Now, if you would have hold these together with a clamp, they would slowly diffuse into each other, and you can tell because there would be different parts of the penny in the screw and the screw in the penny. Now, crystalline solids also have a thing called crystalline structures. Now, the structures are made of units like this. This would be a unit of this. There are 3D arrangement models, and scientists have 7 types of symmetry that they use to classify different kinds of crystalline structures. some more examples of amorphous solids would be a plastic bottle. You can bend it, so that's how you know that it could be amorphous, because usually things that are bendable are amorphous. I believe that's all I have for you today. Thank you for tuning in to Joe's Fun Science Time. That's the name of this. This is officially called Joe's Fun Science Time. Thank you. Talk to you later.